We will now look at more about the lab and labs. The pseudocode is, as mentioned in Appendix B, in the Treasury directory. It's written to be as simple as possible. So there are basically no optimizations in it at all. Instead, it's an example code that you should analyze. You should implement the pseudocode into C. That will train you to express an algorithm in C. So when you have done that, it's very useful information or knowledge. Okay, and then you should use the tools to see why or where this program is not very fast. Okay, and then you can improve it. Actually, there is no requirement that you make the program as fast as possible or at a certain speed. There is a requirement, and that is that you should be able to solve at least 20 of the approximately 3,000 integer programs. If you can solve 20, then it works reasonably well. Of course, there are bugs, but it's good enough for the purpose of learning C, not for solving integer programs, perhaps. Well, not perhaps, but what I'm saying is there may be bugs left, but it should work sufficiently well. Okay? Not even commercial programs work perfectly. In the pseudocode, not pseudocode, but in the Treasury directory, there is a file or tar file with the directory that can be expanded, and there are test cases. We will come to that soon. And some of these test cases, a commercial program found not as good solutions as the program based on this pseudocode. Or actually, the pseudocode is based on that program. Okay? So what I'm saying is that not even commercial programs work perfectly. And you can compare the output in we can do that at once. Let's see, we do like that, and okay, that's fine. So here is okay, where are we? We are in a directory intot. It's we can go there. So this is what you can download, and this file there is the directory with these files, and it contains the test code. So where are we now? Okay, let's go back, and here in the test directory there are certain directories. Two means there are two decision variables and two constraints. Well, maybe there are additional constraints, but at least there are two decision variables, three decision variables, etc. And well, we can go down there and see what we find. We find quite a lot of subdirectories. Okay, so here is what we have, namely there is a commercial program called Gurobi, and it's written by very well-known researchers in integer and linear programming. Okay, and it's one of two best commercial programs. The other one is from IBM, called Cplex. Okay, so what does this look like? Well, we can start with the input to your program. It's like this. So it is the number of rows and columns, I mean decision variables and constraints, and then, well, you can see in the lab how to interpret this. The last row is the B vector. Okay, never mind. But in the Gurobi log, we can print it. It is how it did its solution. Okay, and it let's see what is the output. Okay, the output is in a.sol. Okay, let's print that. So this is the value. Nice that it got the value 42 for this case. I didn't know that. Okay, and then we have some more files, namely int.sol, and it got the same output. So for these files, Gurobi and int.opt, they get the same output. And there are very few cases that int.opt found a better solution than Gurobi. A few, I think there were 3 or something like that, for many thousands of cases. Okay, that does not say that int.opt is better than Gurobi in any way. Well, it was it for these cases, but it's compared to Gurobi, int.opt is extremely much slower. Okay, especially for large systems. Okay, so to test this, you will go through, I mean, there is a program that goes through all this. We can look at it at once, actually. So this main program, it will call your function int.opt, and well, let's see. First, you can say a time, how long it is allowed to run. By default, it's 2 minutes. Okay, and then you can. It's quite boring to wait 2 minutes, so you can. Well, let's look at the makefile. How to do that? You can set up to run 4 seconds, for instance, instead. That's easier to. I mean, it's too terrible to wait. 10 seconds is terrible to wait. 4 seconds is almost okay. Okay, so what does it do? It sets this alarm. Well, actually, it says that when the alarm comes, it will run a program called, a function called timeout. Okay, timeout. It's here. And what it does is to call another function, make score. And make score, it's called at the timeout or at the earliest, at the first error. So your program focus on making it correct, because it stops as soon as there is an error. Okay, so what the program does then is to set this alarm, and it CDs to the test directory. CD is not a standard function, but it's, well, we can see what it is. It is like this. There is a Unix system call called changedir, and if it doesn't work, it returns -1. It usually works, unless somebody removed the test directory or something like that. So we go there, and then eval for each directory in the test, starting with 2 and going up to 20. Okay, so what does eval do? Here it is. It gets an integer as a parameter, and then it creates a string from that, and then it CDs to that string. And does search, and search, what does it do? It lists all files in that directory. So let's see what that looks like. If we if we list all files in a directory, then we use -a. -a means that we will see files that start with a dot as well. They are usually not listed with ls. Okay, so these are the files. Okay, and what we do, now we have done a cd to that directory, then we open this directory, and the name of the current directory is dot. Okay, so if we cannot open it, we call a complaint. And then we have opened the directory with this system call, opendir, and then we search the directory one file at a time. Okay, if it's dot or dot dot, dot dot is the parent directory, then we don't do anything. If the name of the directory starts with a digit, then we go there and continue searching. If it contains a file I, then we assume that there is an integer program there, and we check it. So check, where are you? Here. Okay, so what this program does, what the check does, is to read m and n, and then create data for the matrix and vectors. Actually, this can be seen as a big hint how to do lab 1. Okay, and then it reads everything in the data, and closes the file with the data and calls intopt. Okay, intopt gets back the value. We don't compare the x to see if you made the correct solution or not, since there can be different solutions with the same z. Okay, and then we open this file, which is the output from my program, and well, if it doesn't exist, then we skip it. And okay, if we couldn't read the solution, meaning there was not a numerical value as a solution, we skip it as well. Okay, so let's see. If both your and the reference, the one that produced the solution, got a finite number. If one got the finite number and the other didn't, then we fail and call make score. So then we leave this. Or, if they get different solutions, then we say that they failed. If both say it's not the number is returned when you have an infeasible program, so that the region is empty. Okay, then you should return NaN. NaN means not the number, and you can produce not the number using 0 divided by 0, for instance. Okay, otherwise, if both agree, then we pass, and if the difference between the two solutions is not too big, then they pass or they fail, and we call make score. Okay, what does make score mean? First, it's polite enough to say that your program failed in a certain directory, so that you can find which one was not working. And this system call gets the path to the directory where it failed. Okay, and then it creates the score. Okay, so to create the score, we use the number of past cases for a certain size, and then we shift that by that size. So the bigger problems that you can solve, the significantly higher score you will get. Okay, and then we print this and return. Okay, let's try this. Well, I changed that, but we don't need it. Okay, so let's see what happens. There are error and files, but you can ignore them. So let's create this int opt by copying the header file into the C file and modify it somewhat. Let's make a very bad solution which only returns -1. So this one will certainly fail very quickly. So how should you run this? The only things that you should do in this directory is to modify int.opt.c and type make. Make will compile everything and remove the score file and then run the program. And then, as expected, it failed. So now it didn't pass any test, so the score will be 0. Okay, so that's what we should do. Let's go back to this. Okay, so now we have seen the project directory, so to speak. And what you will do is to go to this website, which isn't up for the moment. And there you will submit your file, int.opt.c, it must be called that. And also you should enter your steel ID. Then Forsite, this automatic grader, will run the program and give you a score. The score is written to to this Power 8 machine, so you can find it. Okay, and the group which gets the best score wins a coffee mug with their names and the course name on it. Okay, so what are you allowed to use pre-written code? Actually, none. You are allowed to use only C standard library functions or code that you have written yourself.